Combining like terms. So hopefully you know what terms are at this point, and we'll review really quickly. So terms in an algebraic expression are separated by operation signs. And guys, we decided that terms are like words in a sentence, or maybe I decided that. So a term is just like a word. And all I have to do to find the terms is to replace each one of these operation signs with a comma. So it would go something like this. 7x is a term. 5 is a term. Negative 3y is a term. And 2x is a term. So each one of these is its own term. Again, a term is basically just a word in an equation, in a math sentence. So let's see what else we've got here. So knowing that, just really quickly, how many terms are in this expression? And hopefully you figured out really fast. We have 1, 2, 3, 4. So since we know what the terms are, what are the like terms? That is a good question. How do I know if they can be combined? When I say like terms, they're the same. So if I said, what are the like terms in my class today? You would look around, and I want you to look at your classmates and look at the boys and the girls. Girls and boys. The girls are one term, the boys are another term. So our girls and boys we can separate pretty easily. Girls would be one term, a like term. Doesn't matter which girl it is. And the boys would be another like term. I could separate you to different sides of the classroom. The other way that I could look at like terms is apples and oranges. Say you dump a bag of apples and oranges on the ground and combine them all together. And I said I want you to sort them into like terms or into piles of just oranges and just apples. You could very easily grab all the oranges and put them in a pile, grab all the apples and put them in a pile, and understand that they're different from each other. So what makes these mathematical terms different from one another? Even though they look alike, what's going to make them different is their variables. So I have a 7x here. And I'm going to look for other numbers that also have a variable of x. 5 doesn't, it's a constant. 3 doesn't, it has a y on there. There we go, 2x. So I have another variable with an x. These are like terms. These two terms could be combined into one term. Just like I could combine all the girls in the room and count them, I can combine these two terms together. So I have 7x's and I have 2x's. When I combine them, how many x's do I have? I have 5x's. Okay, let's keep going and see if there are any other like terms here. I don't think so. I have a 5, which is a constant. Do you see any other constants or just numbers on my screen? No, you don't. So we have just one 5. Next, I have a term that says negative 3y. I do not have any other numbers that have a variable of y. So I'm done combining my like terms for this particular expression. Like terms are terms that have the same variable, like what we just discussed. So if you have all x's or all y's, and they must be raised to the same power or have the same exponent. So in this case, let's see if we can figure out the like terms down here. I have a 7, a 12, and an x. Don't let these parentheses intimidate you. We've learned from the associative property that I can change my parentheses and move them around because all I'm doing is changing the association as long as it's just addition and multiplication. So my like terms here, I've just grouped them together. I have a 7 and a 12. They're the same because they are both constants. They are both just numbers. They have no variables. When I combine them, I will get 19. And I clearly do not have any other x's. So when I simplify this expression, I have 19 plus x. Let's try another example. Oh, we've got steps that I skipped. So we're going to identify the like terms, which we did, our two constants. Next, we're going to use the properties to change the grouping or order, and that's what I did when I put those parentheses in there. And finally, we will combine our like terms. So like terms can be used to create equivalent expressions. And that's what we did. So we changed our grouping and got 7 plus 12 is 19 plus x. These two expressions are exactly the same. They are equivalent. They're balanced. So I want you to see if you can go ahead and help me combine these like terms. And as we do that, we will create an equivalent expression. One thing I'm going to do is go ahead and circle all the things that are the same in the same color. So here I notice I have a 7y. 8 is different. It does not have a y on it. So 8, this would be like, we'll call this an apple since it's red, and maybe this can be an orange. But negative 3y, that has a y, this has a y, so they are like terms. Negative 1 is just a constant. And finally, I have another y, which is the same as these. We know that there's an invisible 1 in front of this y. So I have 3 like terms right here, all with y's. Let's look at my constants because they need combined as well. I have a positive 8 and a negative 1. So I'm going to go ahead and combine those like terms. Oops, sorry. And maybe we'll draw lines to them so I can see them. So if I have 7y's minus, this operation sign needs to come with it, 3y plus, how many y's do I have right here? It looks like, or hopefully you said I have 1y, so plus 1y. So let's go ahead and solve from left to right. 7 minus 3 is 4. Plus 1 is 5. I have 5 y's. Now let's look at our constants. 8 minus 1, that operation sign needs to come with it, equals 7. So my equivalent expression is 5y minus 7. So these two are equivalent. Let's look at the next page. Here's another you do. I want you to try it on your own. Pause the video and see what you can do. I'm going to go ahead and get started. I have a 3x and a 2x. I'm going to underline them both in pink. These are my like terms. Now I'll change my color and look at the constants. I have a 9 and a negative 5. So let's go ahead and group these together. So 3x's plus 2x's will give me 5x's. And then 9, this is just the number 9, minus 5 will give me 4. So I have a 5x minus 4. And this is my equivalent expression. These two are the same. We just went ahead and combined our like terms.